Okay, so now I want to graph a logarithmic function. Because this one's a little bit tricky, it's got a base of 3, I can't just enter it into my calculator, unfortunately, but we can still make a table of values. We're actually going to rewrite the log base 3 of x into 3 to the y equals x. And again, that's just using my definition that's on the second slide, I think, of this presentation. Okay, whatever your base is of your log becomes your base of your exponent. Your exponent is that answer, and it equals whatever you're trying to take the log of by the definition. Really, really focus on where your b's, your y's, and your x's are. That'll help you write that. Okay, so we're going to pick some x values. We got to be really careful because the way this actually gets rewritten is I'm taking 3 to the y power. That's not x. So I got to be very careful what I pick. I want to pick x values that are a factor of 3. That makes sense. Okay, so I picked 1, 3, and 9 because I have to put them into my function carefully. If x is 1, that means I'm saying 3 to what power will give me 1. And you can use your calculator, but anything raised to the 0 power will give you 1. So for this one, y would be 0. Okay? Now the next one, I'm asking 3 to what power will give me 3? The only way to get the same answer back is with an exponent of 1. Next one, I'm saying 3 to what power will give me 9. And you can use your calculator for that, but that will most definitely be 2. So I have 3 points to plot here. I have 1, 0, 3, 1, and 9, which is way out here, 2. And that's going to make something like there. That's going to make another curve. Remember, we just graphed an exponential function. And we just finished graphing that. It might be on its side because it's with a logarithm, but it's an exponential function. So it has a curve. But now we got to look at where that asymptote is. Now your asymptote is on the y-axis when you graph a logarithm. Okay? And again, you use the table of values and made that smooth curve. Let's have you guys try this one. Look at your function very carefully. We want to graph y equals log of base 1/2 of x. We rewrote it as 1/2 to the y power equals x using our definition. We want to pick values of x that make sense for this function. We have 1/2, so we want to pick x values that are a factor of that. We picked 1, 2, 4, and 8. So now we want to put 1 in for x, 2 in for x, and ask ourselves that question. 1/2 to what power will give me 1? Okay, so take a minute and try that, and we will post the answers in just a second. Okay, so you guys tried it on your own. You should have seen when you put those x values in there, you're asking yourself, 1/2 to what power will give me 1? The only way to get 1 as your answer is to have that 0 exponent. Okay, again, we are taking 1/2 to a certain power and we're trying to get these integer answers. The only way to change that 1/2 into those integers is to have a negative exponent. Okay, if we had a positive 1 in there, we would end up with 1/2 again. Remember, when you want to flip it, your exponent has to be a negative. Okay, so we would plot those points. We would get 1, 0, 2, -1, 4, -3, and then 8, -3. So here, our curve is actually going to go along this axis here, the other way. And again, that asymptote is still on the y-axis. Okay, so here is our last example. We're almost done. We want to graph a little more complex of a logarithm. When we want to graph the log of a function like this that has that x plus 3 and a plus 1 at the end, again, we just want to make it a simpler function. We took off the plus 3 and the plus 1 and changed it to y equals log base 2 of x, making it simpler. And we're going to follow the same procedure as we just did. We're going to rewrite it according to our definition. The base to your answer equals your x there. We rewrote it. And we picked values for x that make sense. We have 2, so we picked factors of 2. Avoid picking 0 for x. It'll make things really confusing. Okay, so we have 1, 2, and 4. We're going to put those in for x. That's just like asking ourselves, 2 to what power gives me 1? 2 to what power gives me 2? 2 to what power gives me 4? And these are pretty nice ones. We know the only way to get 1 is if that's a 0. Here, our only way to get a 2 is if that's a 1. And again, this is on your calculator. 2 to the first power is 2. And 2 squared is definitely 4. We go ahead and we plot those points. 1, 0. 2, 1. 4, 2. We draw in our curve. Something you guys can notice is these logarithm graphs are just like exponential decay and growth, except that they're turned. Now we have just the shape. We can worry about those translations. Okay, so we graphed the shape of our curve. Our problem says x plus 3 plus 1. We know from all of our other functions, if I have a number with x, I got to pull the opposite out of there. And that'll tell me which way I'm moving, left or right. So x plus 3 means I'm going to move 3 in that opposite, that negative direction. So 3 to the left. So I'm going to go 1 over 3. 1, 2, 3, and I'm moving every single point. 1, 2, 3. 1, 2, 3. Now I'm not quite done yet with my 3 points there. I have a plus 1. So that means everything is also going to move up 1. So it goes 1.
Alizar, call 5157. Alizar, call extension 5157, please.
And I'm going to draw in that curve. Now let's talk about that asymptote. Now our asymptote is now the y-axis. So it's not going to matter if I move that up or down because it's the y-axis, it's a vertical line. It will change when I move left or right. It's exactly the opposite of your exponential growth functions. So we moved 3 to the left. That means my asymptote is now at x equals negative 3. Okay, so that directly affects my domain and range. Domain, you will notice now, because logarithm is the inverse of that exponent, domain, we're going to look at x's, and I'm kind of looking here. Looks like I have x values that are represented by everything bigger than that asymptote. So my x values have to be bigger than negative 3. Now it's my y values that have no restrictions, so my y values, my range, would be all real numbers. Please make sure that you write any questions you have down in class, down in your notes for class, and we will practice more with this tomorrow.